Hello there, Mr. Sutton here, bringing you the AB Calculus 412 Part 1 homework solutions on motion. For this problem, we have a particle moving along the x-axis with a position given by this x of t function, and a and b are just constants that don't equal each other. For which of the following values of t is the particle at rest? So looking at these different answer choices, it's pretty clear we're going to have an a and a b in our answer in some way, shape, or form. So how can we figure this out? Well, at rest means that the velocity of the particle is going to be 0. So we have to figure out where the derivative of x equals 0. Let's start by multiplying this out so that it's easier to take the derivative. Otherwise, we're going to have to mess around with the product rule. So foiling this out, we've got t squared minus tb minus ta, and then we have a plus ab. Okay, let's go ahead and take the derivative now, keeping in mind that a and b are constants. So we're going to have 2t minus, this is just going to be b, minus a, and then this ab again is a constant, so that's just getting zeroed out. So we want to figure out where this expression equals 0. So to do that, all I actually need to do here is solve for t, because if you look at all these answers, the answer is always in terms of a and b. So to get t by itself, I just have to add a and b to the other side, and then divide by 2. And let's see, is that one of the answers? Why, it is, choice B. So we're done. For number 2, if the position of a particle on the x-axis at time t is negative 5t squared, average velocity for 0 to 3 is, so we're asking for the average rate of change of position if we're asking for average velocity. So we need to do negative 5 times 3 squared minus negative 5 times 0 squared all over 3 minus 0. Basically, y2 minus y1 over x2 minus x1. So this is going to be negative 45 on the top and 3 on the bottom, which we have to simplify to negative 15, which will give us choice C. For this problem, we have a particle moving on the x-axis so that for all times between 0 and 1, its position is given by x of t. We want to know when this particle is at rest. So basically, we need to figure out when the velocity equals 0. So let's find the velocity, or x prime of t, first. That's going to be, let's see, going term by term here, we've got cosine of 2 pi t times a tail of 2 pi plus 2 pi, because this is just a linear term over here. So this was the derivative of that first expression, and then 2 pi t turns into 2 pi. Great. Let's set this equal to 0 now and solve for t. So to do this, we need to isolate the cosine function. So let's subtract 2 pi and then divide by this 2 pi. So 2 pi over itself, that's going to be 1, but we subtracted this, so that's negative 1. Now we need to figure out where cosine equals negative 1. We need the inverse cosine. So on the unit circle, cosine's the x values, and those are negative 1 when you're at pi radians, and also when you're at 3 pi and 5 pi and 7 pi, and every odd multiple of pi is going to give you a cosine value of negative 1. So if we divide all of these by 2 pi to get t by itself, we've got pi over 2 pi, which is 1/2. This is going to be 3 halves, 5 halves, and so on and so forth. But now they just wanted an answer between 0 and 1. And if you look at the answer choices, that's what they're giving us here. So we're going to go with 1/2, choice D. For number 4, we've got a particle moving on the x-axis so that at any time t greater than or equal to 0, position is given by this cubic function. For what value of t is the particle at rest? So at rest means the velocity of the particle is exactly 0. So we need a function for the velocity of this. Velocity is going to be x prime of t, which is going to be 3t squared minus 6t minus 9 if you take that derivative. So we need to set this equal to 0 and solve for t. When I do that, I can factor out a 3. So I can say 3 parentheses t squared minus 2t minus 3 equals 0. And then if I factor it, this factors into t plus 1, t minus 3. Setting that equal to 0 and solving, I've got t equals negative 1 and positive 3. But now they said times greater than or equal to 0. This function doesn't exist before 0, so we can throw out this answer of -1, and it's really just 3 that we care about because we just want positive or 0 t values. So that's going to be answer choice C, 3 only. On this problem, there's a whole bunch of reading. We have the height above the ground of a passenger on a Ferris wheel t minutes after the ride begins, modeled by the differentiable function h. We want to know what's a good interpretation of h prime of 7.5 equals 15.708. So what does this mean in real life? So the key here is realizing that h prime is telling us the rate of change of the height of the Ferris wheel, and that's going to be in meters per second as a function of time. So we're plugging in time and we're getting out meters per second. So that's what h prime is doing, rate of change of passenger's height over time. Let's look at the answer choices and see which one has an input of time and an output of change in height. So choice A, Ferris wheel is turning at a rate of so many meters per minute when the passenger is 7.5 meters above the ground. First off, we don't have anything telling us how fast this Ferris wheel is turning. We just have something telling us how the height is changing. So this already is kind of fishy. And then they're talking about 7.5 meters above the ground. Well, the input here is not meters, it's time. It's whatever the time is. What's the time here? Minutes. So choice A is bogus. Choice B, they're again talking about how fast this Ferris wheel is turning, but we don't care because again, h prime is rate of change of height. Choice C, the passenger's height above the ground is increasing by this many meters per minute, so that part is good. When the passenger is 7.5 meters above the ground. Again, they have the wrong input here. They're plugging in height rather than time. All right, choice D, passenger's height above the ground is increasing by this many meters per minute, 7.5 minutes after the ride begins. So that's a little bit more like it. Now we have an input of time and an output of rate of change of height. Let's just look at E, though. I mean, D's looking pretty good. Let's look at E just to be sure. Passenger is 15.708 meters above the ground, 7.5 minutes. So this one, they have the right input, time, but now they're saying that h prime is just height, and that's not true. It's rate of change of height. So choice D, then, is the best answer out of all of these. For number 6, we have a particle moving along the x-axis so that at any time its position is given by this function. We want to know at what values of t the particle is at rest. So we're basically asking where the velocity, which is the derivative of this thing, is 0. So to find the derivative of this thing, I'm going to use my product rule, u prime v plus uv prime. For that, I'll use my box and ribbon. So we've got the factors t and e to the negative 2t, and their derivatives 1 and negative 2 e to the negative 2t. Doing the ribbon now, I've got 1 times e to the negative 2t minus, this will be 2t e to the negative 2t, and that's all going to equal 0. I can solve this by factoring out an e to the negative 2t. That'll leave me with 1 minus 2t inside of parentheses. Setting each of these factors equal to 0 and solving now, we've got this first one equaling 0, and there's no way to make an exponential 0, so that's just a no. But this next one, if I subtract 1 and divide by negative 2, I have t equals 1/2. This is the only place where we're able to zero out the velocity function, so that means that it's 1/2 only, choice C. On this problem, we have a particle moving along the x-axis with a position given by this x of t function here. We want the first time at which the velocity of the particle is 0. So we need a formula for the velocity of the particle. V is just going to be x prime of t, and for that we are going to need to use the product rule here to take that derivative. So we've got 12e to the negative t, I'm just using my box and ribbon here, and then we've got sine of t. Derivatives, this is going to be negative 12 times e to the negative t, and then this will be cosine of t. All right, we've got the box. Time to use the ribbon to multiply all this out. So I've got negative 12e to the negative t sine of t plus 12e to the negative t cosine of t. Now, to get to the bottom of this, when I set this equal to 0, I'm going to factor out a negative 12e to the negative t. So when I do that, setting this equal to 0 here, I've got just sine of t, and then this is going to be minus, and then we'll have a cosine of t over there. Okay, so negative 12e to the negative t, how can we make that equal 0? Well, the short answer is we can't. E always comes out positive. If you put a negative out in front of it, it always comes out negative. It's never going to come out to 0. So we're just stuck with this sine of t minus cosine of t business. Now, there's a few ways to do this. You could ask yourself, okay, what angle do I have to plug in where the sine and the cosine of the angle are exactly the same? And maybe you remember that that's 45 degrees. It's radical 2 over 2 for sine and cosine there. Another way you could do it is add cosine over here and then divide both sides by cosine, which gives us tan of t equals 1. And this is legal to do because we're guaranteed sine and cosine can't both be 0 at the same time, which means that we're not dividing by 0. Anyway, inverse tan of this, that's going to come out to pi over 4, which gives us answer choice A.
On this problem, we have the position of an object attached to a spring given by this y of t function, this crazy kind of hybrid cosine-sine trig function, and time is in seconds. They want to know in the first 4 seconds, how many times is the velocity of the object equal to 0? So our strategy of attack on this one, since the motion is given by y of t, we need to find y prime of t and see how many times that hits the x-axis, basically, by graphing it out. It is a graphing problem, but we need to find y prime first. So let's go through and do that. So starting with 1 over 6 cosine of 5t, the derivative of that, we have a little bit of a chain rule involved. This is going to be negative 1 over 6 sine of 5t times the tail of 5, the inner derivative of 5. So that's actually going to be negative 5 over 6 sine of 5t. And next we'll do the second term here. Derivative of negative 1/4 sine of 5t is going to be negative 1/4 cosine of 5t times the derivative of the inner stuff, so that'll be a 5 out there. So then grand total of negative 5/4 cosine of 5t. And this is what we have to figure out now, how many times this is equal to 0. So let's go to Desmos and do that. Now, when I graph this out, I'm just going to call this f of x. Doesn't really matter. You could use t if you wanted, but I'm more comfortable using x, and I know the graphing calculator prefers x anyway. So we've got negative 5 over 6, and then sine of 5x minus 5/4 cosine of 5x. And again, we're just seeing how many times this equals 0 on the interval from 0 to 4. So let me pull this up and change my interval. I'm going to make this go on the x-axis from, we'll do negative 0.5 to 4.5, just so I can see the full interval. And here's what we're looking at. So if I click on the function, I get my gray dots where I'm crossing the x-axis. So we've got 1, 2, 3, 4, 5, can't really see it, but 6. That's 6 times we're crossing before we get to 4. So here's my graph, and that was 6 times. So this tells us that our velocity of our object equals 0 6 times. Choice D.
On this problem, we have a bug beginning to crawl up a vertical wire at time t equals 0. Velocity is shown in this graph here between 0 and 8. And we want to know at what time t the bug changes direction. So the key here is recognizing that they have given us the graph of the velocity, not the position or the height or anything like that. And we know that the direction is going to change when the velocity changes its sign. So looking at our graph, the only place that actually happens is here at 6, where we're changing from positive velocity to negative velocity. So since that happens at 6, we can say choice C is our answer.
For this one, we have a particle moving along the x-axis so that at time greater than or equal to 0, the position of the particle is given by this x of t polynomial function. We want to know the velocity of the particle at the first instance the particle is at the origin. So strategy on this, we need to figure out at what time this x here equals 0, because that's what at the origin requires. And then we need to take whatever that time is and plug it into the velocity of this thing. So this is all a calculator-based question. So what I'm going to do first is figure out where x of t equals 0, and I'm going to go to Desmos for that. So here is Desmos, and let me input this function here. Now when I do this, I'm not going to use x of t because weird things happen when you try to use x as the name of a function on Desmos. I'm going to use f of t instead. That should be close enough. So we've got 0.5 t to the fourth minus 1.5 t to the third minus 2t squared plus 6t minus 1. Let's just carefully put that in there. And then zooming in a bit here, the first time that I am crossing the x-axis in positive territory is right here at 0.179 if I round that off. So there was my picture, and time 0.179. So that is the time, and I can yank the exact value off of Desmos here, but that's the time I have to plug into the derivative function. Now, since I'm just taking the derivative of this function at a single point, I don't really need to figure out what the derivative is algebraically. I can just go to Desmos and actually just put in my function prime with this number plugged into it. So back on Desmos, let me go down here now, and let me actually get this value again, and I'm just going to copy it. So Control C to copy that. Now let me go down here, and I'm just going to do f prime of that number that I just copied, and this comes out to about 5.153. So that is the velocity, and that's going to match choice D. On this one, we have a particle moving on the x-axis with the velocity given by this v of t function, and this is on the interval from -3 to 3. We want to know how many times the particle changes direction as t increases from -3 to 3. All right, so this is a calculator question. Basically, all we need to do is graph v of t on Desmos and see how many sign changes we have. So we can say v of t changes sign how many times? Well, let's go to Desmos and find that out. So I'm just going to put my v of t function in here. So 3t to the fourth, and then minus 11t squared plus 9t minus 2. And we want this on the interval from -3 to 3. So let me just adjust that so I can focus in. I'll just do -3.5 to 3.5 so I can see a little bit beyond my interval. All right, so we were asking how many times we changed sign. That is happening twice. Once right here and once over here. This one, it's kind of ambiguous as if it's changing sign or not, but if you zoom in, you see we're not even actually hitting the x-axis there. So here's our graph, and we see we just have 2 sign changes, so that means that our particle is changing direction twice. So that would give us choice C.
For question 13, this table above gives the distance in miles a car has traveled during a 6-hour trip. The graph of S is increasing and concave up, they're telling us. And so that means that no matter where we are, even in between these values they gave us, we're increasing and concave up. Based on that, which of the following could be the velocity at time 3? So the way to do this, if we could at least figure out the average velocity between 2 and 3 and the average velocity between 3 and 4, since this graph is concave up and increasing, since your velocity, in other words, is always increasing, that means your actual velocity at 3 has to be between these 2 average velocities. So let's go ahead and do that. For the average velocity from 2 to 3, we've got 92 minus 55 over 3 minus 2. This was a calculator question, but you might be able to do it in your head. I wouldn't recommend it, but it's 37 over 1, so 37. And then the average velocity from 3 to 4, that's 150 minus 92 over 4 minus 3. So that comes out to 58. So that means our true velocity, the instantaneous velocity at 3, has to be somewhere between 37 and 58. So that's any number in that interval, which 49 is the only number that they gave us that meets that criteria. So choice B.